Hi students, good morning everyone. Now we are going to talk about Unit 14, Haloalkenes, Haloalkanes and Haloarenes. What is the Haloalkanes and Haloarenes? Halo means halogens groups, fluorine, chlorine, bromine, iodines. Alkanes means aliphatic groups, methane, ethane. Alkanes means hydrocarbons, methane, ethane, propane, etc. And Haloarenes means benzenes and the ring structures, benzyl groups. Okay, first one, alkyl halides or haloalkanes or X. Compounds containing sp3 hybridization CX. Carbons containing sp3 hybridization. The halogen atom is bonded to an alkyl group. The general formula CnH2n plus 1 X. They are classified as primary, secondary, tertiary according to the nature of carbon to which halogen is attached. This is primary carbon, this is secondary carbon, this is tertiary carbon. This is allylic halides. Allylic means double bonds. The halogen is bound to the sp3 hybridized carbon atom next to carbon-carbon double bonds. This is allyl bromide. This is 4-chloro-1-butane. This is 3-chloro-cyclopentene. This is benzic halides or haloarenes. The halogen atom is bound to an sp3 hybridized carbon atom next to an aromatic ring. It's a benzyl chloride diphenyl methyl bromides. Organic halogen atom is an organic halogen compounds classified two types based on number of halogen atoms. Next one, based on hybridization carbon atom attached with hydrogen. This number of halogen mono, poly, say mono, one bromine is added, therefore mono halo compounds. This is more than chlorine or halogens added, this is polyhalo compounds. Based on hybridization of carbon atom attached with halogens, two types. Compounds containing C carbon means sp3 hybridization X bond, carbon containing sp3 X bond. Alkyl halides, allylic halides and benzylic halides and alicyclic halides. And another one, vinylic halides and aryl halides. So IUP is name of haloalkanes, CH3I, methyl iodide. This is ethyl bromide. This is N-propyl fluoride. This is isopropyl fluoride. This is N-butyl chloride. It is common name. IUPAC name iodomethane. Bromoethane. This is fluoropropane. This is 2-fluoropropane. This is 1-chlorobutane. That's all. So polyhalogen compounds. Polyhalogen means one or two or more than two. This is monohaloalkanes. The haloalkanes compounds. This is dihaloalkane, two halogen atoms. This is X means halogens. This is monohaloarene. This is dihaloarene. This is trihaloarene. This is trihaloarene. This CX bond. The CX means carbon to halogens bond is found by overlap sp3 orbital. This is overlap sp3 overlap because how many sigma bonds? 1, 2, 3 and this one 4. More than 2, 1 sigma bond, 2 sigma bond, 3 sigma bond, 4 sigma bond. Therefore carbon is sp3 hybridized. The CX bond is formed by overlap of sp3 orbital of carbon atom with half-filled p orbital of the halogen atom. This is half-filled p orbital. The atomic size of halogen increases from fluorine to iodine, which increases the CS bond length. Larger the size, greater is bond length, and weaker the bond formed. The bond strength of CS decreases from CF to Ca and CH3X. They change the value of bond length, bond enthalpy, and bond polarity as we move from CF to Ca. This is haloalkanes, preparation of haloalkanes from alcohol. Ethanol, reacts with Lucas reagent HCl and mixture of zinc chloride. Uh, Alcohol reacts with Lucas reagent to form alkyl halides, chloroethane. Order of reactivity: iodine is a high reactivity, and next bromide and chlorine. This Dodson's halogenation. Alcohol reacts with thionyl chloride to form alkyl haloaride. Sorry, haloalkanes, chloroethane. And from alkenes, double bond is broken. So hydrogen is added one side and chlorine is added another one side to form CH3, CH2, CHCl, CH3. From alkanes means hydrocarbons. The hydrocarbons reacts with chlorine and light to form alkyl haloalkanes. Again react with chlorine removal of HCl and same process, and CH2Cl2 again reacts with chlorine gases, and again product CHCl3 again reacts with Cl2 to form carbon tetrachloride. From alkanes reacts with chlorine gas to form many products. Next one, exchange reactions. CH3 CH2Br. This is bromide halides. Haloalkanes reacts with sodium iodide. To exchange means bromine go to NaBr, I go to CH3 CH2I. This is Finkelstein reaction. Next one, Schwartz reaction. AgF reacts with CH3 CH2Br reacts with AgF. Same process, AgBr go to AgBr and CH3 CH2Ef. These reactions. Next one, same CH3 CH2Br and CO2 and AgBr. Physical properties. This is haloalkanes is colorless. Bromoiodoalkanes are colored in the presence of light. And carbon 1, carbon 2, carbon 3 haloalkanes gases, and the others liquids and salts. Others means more than carbon 4. And highly binding and melting point. And lower order of this process: iodine, bromine, and chlorines and fluorines. Halogen increase the number of order: chlorine 1, chlorine 2, chlorine 3, chlorine and 4 chlorine. And number of carbon atom increase the process: 3 carbon atom, 2 carbon atom and 1 carbon atom. This is polar carbon compounds, soluble in only organic compounds, higher than hydrocarbons density, because density is higher than hydrocarbon. Or hydrocarbons compared to hydrocarbon, higher is haloalkanes. Chemical properties. So, haloalkanes reacts with potassium hydroxide to form alcohol. This process is hydrolysis process. And haloalkanes react with NaSH, sodium thiohydride. They react to form CH3 CH2 SH. Remaining Na and Br go to NaBr. Next one, reacts with ammonia. This reaction is ammonolysis to form go to HBr. Remaining HBr. This is HBr. Next one, to form CHNO2. Next one, KNO2, potassium nitrate, to form ether. KBr go to, this is KBr, and remaining O, single bond N, double bond O. Next one, KCl, potassium cyanide. KBr is released, and CH is CH2 CN, and Ag plus CN minus AgBr is not CN, NC, isocyanide. Next one, AgNO2, Ag plus NO2, AgPr, CH2 NO2, and NaOCH2 CH to form ether. This is unsymmetrical ethers. This is unsymmetrical ether to form symmetrical ether. So very important questions: SN1 and SN2 reaction and E1 E2 reaction. What is the SN1 SN2 reaction? 1 means unimolecular, 2 means bimolecular. unimolecular substitution reaction. Unimolecular nucleophile substitution, bimolecular nucleophile substitution reaction name. The difference between SN1 SN2 rate law, unimolecular substitution reaction, unimolecular nucleophile substitution reaction, bimolecular nucleophile substitution reaction. Big barrier is only carbocation stability. This is steric hindrance. Alkyl halide electrophiles is a worst electrophile, the same one, primary, the secondary, this one. Next, nucleophile is weak. This is nucleophile is strong nucleophile. Solvent, this is polar protic solvent. This is polar abrotic solvent. For example, polar abrotic alcohols and polar abrotic TMSO acetones and etc. First one, what is the SN1 reaction? It's a stepwise mechanism. First one, this is CH3, 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 the tertiary alcohol, tertiary bromide, breaking of C bond. This is go to listen, Br minus. This is plus to form. This is to form carbocation. Again, yeah, another one halides group is added, halogen is added to form alkyl halides. Sorry, haloalkanes. This is nucleophile attack. This is nucleophile. This is nucleophile. Therefore, the attack is called nucleophile attacks. Only single step. This mechanism of SN2 reactions. Nucleophile attack by hydroxide on the carbon atom of ethyl chloride result in a pentocoordinate intermediate carbanion. OH minus a nucleophile attack to sodium hydroxide attack to this place. This is carbanion is formed. This is intermediate step. Na plus is remaining Na plus. The Na plus the carbanion. The bond is entered. The bond is entered. Therefore, the bond is break. The NaCl is cancelled to form HCH. This is ethanol is formed. This is two steps. Next one, E1 E2 mechanism. E1 means unimolecular elimination reaction and bimolecular elimination reaction. Formation of carbocation known. Next one, require strong base. No, this is yes. Serial chemistry no requirement. Leaving group must be anti to hydrogen removed. Comparing to SN12 and E2 or SN2 reaction, strong base nucleophile and bimolecular. So listen, this is SN2 reactions. This is alkyl bromide reaction with Cn minus is a good nucleophile to form Cn and Br minus cancel. The same process E2 reactions. Cl minus is cancelled to form the bonds. The bond go to this place. Therefore, to form this process. Reaction with metals. Reaction with metals. Haloalkanes reacts with sodium magnesium metal to form Grignard reagent. Grignard CH3 CH2 MgBr. Next one, metal reacts with lithium to form CH3 CH2 Li and LiBr. Next one, haloalkanes reacts with sodium lead amalgam to form lead bromolate and metal haloalkanes to form NaBr. Reduction reactions. This is reduction reaction. Haloalkanes react with hydrogen. One hydrogen is added, another hydrogen is to form HCpR. This is HCpR. Remaining CH3 and CH3 is a hydrocarbon is added. Next one reacts with hydrobromide and red phosphorus to form Br to cancel. This is Br2. Hydrogen is added. There was CH3. Organometallic compounds. This direct carbon metal bond. This product is called Grignard reagent product or MgX. This is Grignard reagent product. Methyl iodide reacts with magnesium metal in the presence of dry ether to form Grignard reagent. Same process, primary and secondary and carbocations. Secondary, primary, secondary, tertiary ketones reacts with Grignard reagent to form alcohols. Preparation of aldehydes. Ethyl formate reacts with Grignard reagent to form aldehydes. Aldehyde. However, with excess of Grignard it forms secondary alcohol. Aldehyde is oxide alcohol. Preparation of ketones. Acid chloride. This is acid chloride reacts with Grignard reagent to form ketones. However, the excess of Grignard is formed tertiary alcohol. And preparation of carboxylic acids. Solid carbon dioxide reacts with Grignard reagent to form addition product which an hydrolysis yields carboxylic acid CgCOOH. And preparation of ester. Ethyl chloroformate reacts with Grignard reagent to form esters. And preparation of higher ethers. Lower halogenated ether, this is chlorodimethyl, this is unsymmetrical ether reacts with Grignard reagent to form ethyl methyl, which is unsymmetrical ether. And preparation of alkyl cyanide. And preparation of alkyl cyanide. Grignard reagent reacts with cyanogen chloride to form alkyl cyanide. This is Grignard reagent reacts with cyanogen chloride to form alkyl cyanide, remaining MgCl(I), methyl cyanide. Next, preparation of alkanes. Compounds like water, alcohols, and amines which contain active hydrogen atom react with Grignard reagent to form alkanes. This Grignard reagent reacts with water molecule, hydrogen added, CH3, CH4 converted to CH4, MgIOH. Same process. Next one, haloarenes. Haloarenes are the compounds in which the halogen is directly attached to the benzene ring. This is IUPAC's name. How many chlorine? How many halogen attached? 2 attached. 1, 2 dichlorobenzene. 1, 2, 3. 1, 3 dibromobenzene and 1, 3, 5 tribromobenzene. Next one, benzene. This is halogenation. Benzene reacts with chlorine molecule to form chlorobenzene. Benzene reacts with chlorine molecule in the presence of FeCl3 trichloroferric chloride and to form chlorobenzene. Next one, reaction with benzene diazonium chloride. Benzene diazonium chloride reacts with Sandmeyer. This reaction is called Sandmeyer reaction and or Gattermann reaction. So Cu2Cl2 and HCl is called Sandmeyer reagent. Cu and HCl is called Gattermann reagent to form chlorobenzene. That's all. N2 is cancelled. Another one reaction, benzene diazonium chloride reaction with potassium iodide. In the warm to form iodobenzene. I go to this place, nitrogen and KCl is formed. Next one, benzene diazonium chloride reacts with tetrafluoroboric acid. This removal of HCl to form CCH5N2 BF minus. Again heated to form C6H5F and BF3 and N2. Benzene reacts with hydrochloric acid and oxygen gas and the cuprous chloride to form chlorobenzene. Chlorobenzene reacts with this is chemical properties. First reaction is Dow process. Chlorobenzene reacts with sodium hydroxide to form phenol. Phenol means alcohol. Next one, chlorobenzene reacts with ammonia to form aniline. Removal of HCl, removal of NaCl. This is removal of CuCl. Therefore, cyanide, phenyl cyanide. Next, Woods-Fittig reaction. Chlorobenzene reacts with sodium and chloroethane. Chlorobenzene reacts with sodium and chloroethane in the presence of ether to form ethyl benzene. In presence of ethyl benzene, go to ethyl benzene and 2 NaCl cancel. This is 1 Cl and 2 Cl, 2 Na. Therefore, 2 NaCl cancel. So, remaining C6H5 and C2H5. This is ethyl benzene. There is a Fittig reaction. Next one, Fittig reaction. Same process. Haloarenes chlorobenzene reacts with sodium and chlorobenzene, again chlorobenzene to form 2 NaCl cancel, remaining CCH5, CCH5. This is 2 phenyl compound, therefore biphenyl. Next one, chlorobenzene reacts with halogenation. Halogen means any halogens to form alpha dichlorobenzene or para dichlorobenzene, and nitration to form alpha chloronitrobenzene and para chloronitrobenzene. And sulfonation H2SO4, therefore HSO3, alpha chlorobenzene sulfonic acid, para chlorobenzene sulfonic acid. This one, Friedel-Crafts alkane, AlCl3 and CHCl3 is a reagent, and CH3 is alpha chlorotoluene, para chlorotoluene. Chlorobenzene reacts with hydrogen. Next one, chlorobenzene reacts with hydrogen in the presence of nickel aluminum amalgam and sodium hydroxide to form benzene gas. This is to HCl and Cl go to HCl gas, and remaining chlorobenzene reacts with magnesium metal to form phenyl magnesium chloride. This is Grignard reagent, aryl Grignard reagent. And the use of chlorobenzene. Chlorobenzene is used in the manufacture of pesticides like DDT. At least, second point, it is used as high boiling solvent in organic synthesis. Dear students, watch this video 2 or 3 times so that you can understand the concept well. Raise homework questions. Write preparation of haloalkanes and write preparation of haloarenes, and explain Grignard reagent reacts with metals. Okay, these 3 questions for you. So you have think and answers and study and write 3 times in your home test note and send it my personal WhatsApp number. Thank you students. God bless you.